Hello and welcome to the second part of my first look at geometry nodes in Blender. In the first video, we looked at how it all generally works with the modifiers and the node trees. In this video, we're going to take a look at the attribute workflow. Before we get started though, I have a question for you. I recently got my 3D printer and I've already made some practical custom made 3D prints. And I designed stuff in Blender and then 3D printed it. I was wondering, do you have a 3D printer? Are you interested in that kind of workflow? Are you already using Blender and 3D printing? What aspect of it all would be most interesting to you? Please write a comment down below. Now it's time to jump into Blender and look at geometry nodes. Alright, here we are in Blender and I already prepared this scene a little bit. So what I've done here is I have this outer orb sphere thing and I already added a geometry nodes node tree to this, and I added all of the nodes from this menu here, the attribute menu. Okay, they're all here so we can take a quick look at what we got. Okay, so first thing we notice is that something I mentioned in the last video, every node has geometry in, geometry out, right? They all have that. Then we can also see here that most nodes have this thing that I also mentioned, where we can actually change the behavior of the node with these drop downs. So for example, here I defined that the A input here is an attribute, but I could also change it over to be a float. Now it's a float. Or a vector. Now A is a vector. And we can see this all over the place here. Okay, so the most important thing, of course, is the attribute aspect of it all. We can use attributes, and an attribute is just a name, basically. And we can type in the name. So this node, for example, has two attribute inputs, if we want them to be attributes or something else. And then we have a result, and the result is an attribute. So how does that work? The geometry, or each node in the geometry, each vertex has attributes. By default, it has a position, a scale, and a rotation. Even though it's just one point, it has these attributes. But we can also define our own attributes and add them onto each point. Part of this whole geometry workflow that goes through our node tree here. So if we want to change, for example, the size, we have to type in the attribute size. If we want to create our own attribute, we just assign it a value, and then later on in the node tree, in that branch of a node tree, we can use that attribute and base some calculations on it, for example. So when we look at this node close up, these are inputs, but this is actually an output. Okay, it doesn't have an output socket. It's just that we're outputting the value onto an attribute using this node. But the value, or the stored attribute on the geometry, is actually part of the geometry then. So it doesn't have an output. Only a geometry output exists here, and the attribute that we assign to the geometry will be part of this, whatever's coming out of this node here. You might also notice that this sockets, or this output, actually has an input socket, so we can actually even modify the name of the attribute that we want to set in an animation, for example. Okay, so this is interesting to know, because we don't have the attribute as a socket, we don't have to pipe the attribute through. We kind of have to follow the path that we have in our node tree to know what value exists. And maybe in the future we get some sort of UI for this that shows us maybe in the 3D view which point has which attribute value assigned to it, something, because it becomes a bit confusing using this way. Just like with the UI here, I think that this drop down here should be down here. It's kind of confusing that we change something up here and it changes the value, the data type down here. But maybe this is just currently not possible. Maybe they're also going to work on this. Okay, so we have all of these nodes. We have an attribute color ramp. We already know what the color ramp node is, right? It clamps the values, and you can define like stops inside of that color ramp to modify colors, or if you use black and white, you can modify the value like between 0 and 1. We have an attribute compare, which is just like a compare node, less than, greater than, equal. You have two inputs, which can be attributes or floats, or even colors and vectors and booleans. Let me zoom in a little. And then the result of that compare operation can be put into a new attribute. And we have attribute fill. This is quite obvious what that does. It just assigns a single value to an attribute. You can, like always, you can use an attribute that already exists, like scale or rotation, or you can use your own one. We'll look at this in a second. So then we have math. Well, this is just a math node with all of the math operations based on 2 inputs and 1 output. Attribute mix. These are all the blend modes that you know from the mix, the RGB mix node actually. So you can mix. This is a very powerful node. You have a factor, which can be an attribute or a float. So this would be your mix factor that you know from the shader nodes. And then you mix the 2 inputs and you assign it to an output. And this is, again, this is the output on the geometry. Then we have attribute randomize, a very cool node because this actually makes things look interesting. So we can randomize the size, for example. We have attribute sample texture. So we can plug a texture in here and use that to randomize the size, for example, or the rotation, or some other value that you want to base on a texture. And then we have vector math, which is basically the same thing as the math node, but in this case with vector operations like distance, dot product, and so on. So these are the attribute nodes that are currently available. I'm sure there will be more in the future. Now, how about we put together something that we can try out what all this attribute stuff is all about, because you really have to see it in action to actually understand how it works. So how about I'm gonna take my outer orb here again from my startup file. Maybe I'm gonna switch over to matcap and maybe this one because it looks cool. Okay, so let's create something. Let's do a point distribution like we did in the last video. So we take our original geometry, plug that in here. Then we also take a point instance, and we need something to instance. So let's just take a cube, very simple. Go back here and I drop the cube in here. So now we're instancing our cube onto these distributed points here. How can we do something with the attribute now? Okay, so for example, we take the attribute randomize node. I'm just going to copy it and put it in here. And we have to type in the attribute that we want to change. So the size or the scale is the attribute scale. Each point already has that attribute, and now this node is changing the attribute, and we can input some values in here. For example, something between 0 and 0.2. So now we have this. So we have random sizes of our cubes. Okay, we can maybe increase the density a little, so we get this cool looking thing. Awesome. So now we're changing this attribute called scale. What if we introduced our own custom attribute? Maybe call it size. So now we're assigning a new attribute to each point in our point cloud, and it's called size. But of course, these cubes up here now, they all have their original size, or some size, and this node is not doing anything with, basically. It just adds this attribute. So coming out of here, the geometry has this attribute. Let's see what we can do with it. Well, first of all, let's see if it's really there and if it's working. How about I just take a color ramp, I take my size and plug it into the scale So I'm back to just plugging scale in here, and yes, it works. And we have the color ramp functionality in here, where we can do this kind of stuff. We can flip the color ramp, manipulate the sizes like this. Yes, this attribute size is in this geometry coming out of here, and yes, we can use it. And of course, this node doesn't get rid of the attribute, it still is in here, so we can still use it here. How can we prove this? For example, let's take another node. I'll pick one from down here. Let's do attribute math maybe. I'm gonna shift D that, plug it in here. I'm gonna multiply the attribute size with some value, 45. Oh, yeah, this is also one of those things that where the UI here is kind of confusing. This is now an attribute, it's not a value, so this does not work. You have to set this to float to make this a value, and then we can enter the value, 45, and let's output this to rotation. So now we have random rotation based on our original, maybe we should call it rand. Okay, so now everything is gone. Take rand here and take rand there, and we have random size. Yep, and we have random rotation. And it's all based on this single attribute that we added at the beginning of our branch here in the node tree. So this is already very cool. Yeah, so the UI here, like I said, is a bit confusing. I wish that this dropdown was down here somehow, and maybe also, I mean, it is visually different, right? Attribute looks like this and float looks like this, but still, when you look at it just like this, you might think, oh well, multiply this by something, but that doesn't work. So maybe the UI could, I mean, yeah, the color here changes too. I don't know. It's still a bit confusing to me. I have to get used to this, I guess. But the main thing to take away here is that the geometry has attributes on it. So each point has some attributes on it. It has some default attributes like position, scale, and rotation. And we can also use our own attributes. We can add them, we can use them later. And you just assign new values to a new attribute by just typing it in here. So you don't have to do anything special, just give it a new name and then use it. And as I've mentioned before, it would be kind of interesting to sort of plug in a viewer node or something in here to actually know and see what is rand for each point at this point in my branch. Maybe in the future we get something like this. Okay, so we are already using some attribute nodes, and we already know how it works. We have more nodes that we can play with. So maybe let's play with the attribute sample texture. Not like this. Let me just copy it, put it up here. And I'm just going to leave this all down here but not use it. So I'm plugging my geometry in here now. Plug this into the output. So we get this. So this is our input geometry. Point distribute. So we have points. And then we want to do something with this sample texture here. So first of all, we need a texture. Can go down here to the texture panel. Take a clouds texture. Sure, why not? Can we maybe increase the contrast a little so we can actually see something? And also we're not doing anything with it. Oh, that's because we actually want to plug this in here and have the point distribute, right? So we get our cubes, and then we use this texture in here. Which one is that now? I just reused one, compositor background. Well, it doesn't matter. Let's use that. Then we need to define mapping and result. So result will be the attribute that we want to change based on the texture. Let's change the scale. And we need to map the texture onto this object. And I believe this object does not have a UV map. Or yeah, it does have a UV map. So we just type in the name of the UV map as an attribute for the mapping. So this is UV map. And now our texture here, if I change this, should actually change the size, the scale of our nodes here. And yes, it's working. Okay, so we have this. Now maybe let's try this on a new object. So let's plug in a plane, scale it up a little, move it over, and let's take this plane, give it a geometry nodes modifier, and use the geometry nodes node tree that we already have. So now we have cubes on this plane. Actually, the plane is gone because we're replacing its geometry, but we have those cubes now. So how about we take this texture, or maybe we make a new texture. Let's make a new texture, call it I don't know, image. Let's plug in an image. Pick an image. For example, I have this logo here. So this is now this texture called image. Let's plug that in here, right? So we get this, and I don't know if it's already working, but might be just a little bit too big. So how about we take our points that we have here, and we take an attribute math. We take the scale, we multiply it by 0.1, and we output the new value onto scale. And same thing again, this needs to be a float, 0.1. So we have this, okay. So let's crank up the density, and you can see since this modifier and this modifier, they're both using the same node tree here, that we're also changing the look here on the orb. But if we look at this top down now, and we increase the density, we do get something here. Maybe take this down even further, something like this. And if I crank up the density, you can see we have my texture logo here. So the texture is now influencing the scale, which means texture is black means scale is 0. So we have a whole bunch of dots here or points here, but the scale is 0. That's why we don't see anything. And here, where the texture is brighter, we have a scale, and we can actually, we could even plug in a movie now and have this animate. So this is cool. Attribute sample texture node. Now let's try something else. How about we try to influence the size of our cubes on this plane based on the distance to an empty, right? Cool, so let's reuse all of this again. We're gonna distribute the nodes. This is our output, and we instance the cubes. And then up here, first of all, we're gonna need an empty. So when we look at this like that, this is what we have. You know what, just to keep things simple, I'm gonna edit my cube and scale it down quite a bit. Okay, so we have something like this. Okay, back to this. Okay, so we need to calculate the distance. Add empty sphere. Where is it? Let's put it over here. Now we go back here. We can calculate the distance with an attribute vector math, and we need the position of the empty, so we need an input object. Let's put the empty in here, and that gives us the location. So we take vector for this input, location, and then we want to use an attribute. We want to use the position of the point of this point cloud. And we want to calculate the distance. And the result we plug into, let's just plug it directly into the scale for now and use that for our point instance. So what do we get? If I move this around, the further away the point is from the empty, the bigger the distance and the bigger the size. So this is what we get. Cool. Also, when the empty is over here, we get 0 distance. So it looks like we have to go in here and switch the object info of the empty to relative. And now when I move the empty over here, this is what we would expect. So the point has a distance to this empty. Each point is being calculated individually. And where the distance is 0, we get 0 size cubes. And then where the distance is larger, we get large cubes. And of course, this also works if I keep moving the empty away. The cubes get larger and larger. If you want to clamp that, you can, of course, clamp that. So how about we clamp it? Easiest way to clamp is with maybe an attribute color ramp node, right? That clamps things. So shouldn't go over 1. Oh, I completely forgot I have to put this in here. So I want to clamp scale and I'll put it to scale. So now when I move the empty away, they don't get bigger than a scale of 1 because white is 1. Okay, what else? Instead of the color ramp, what else could we do? Let's play around a little. What if we take an attribute math node, plug that in here, and what does that give us? How about ping pong? Geometry scale, float 1, result scale. So now if I move the empty, we get this cool effect. And it's all just one node. This is really cool stuff. And also I have to mention that this is way more performant and snappy compared to animation nodes. And you can see we're also doing it over here because this still has the modifier using the same node tree on it. Okay, so you can create some really cool like wavy ripply effects. Let me just put it over here so it looks interesting. And we're only playing with the scale now, but of course we could, let's randomize the rotation as well. Why not? Attribute randomize, plug it into the stream, and we want to randomize the rotation. So we already have random rotation now. Cool. Can increase this. And now this is a uniform rotation in X, Y, and Z. If you wanted to rotate this, maybe only rotate the Z axis, then you switch over to vector here, min, max, and we don't rotate the X, or don't rotate the Y, we only rotate the Z axis. Now let's try to use maybe the same distance. So how do we do that? First of all, we calculate the distance. Let's not influence the scale right away. Let's just give it a new attribute, d for distance. For the scale, we use our attribute d. Now, we still have d in here. We also have a new scale in here. Now we want to influence the rotation also based on this d value. And this is where I would think that I have to do this like in parallel based on this same input. But you don't. At the geometry nodes, the whole attribute thing is always one long branch of nodes, always changing attributes in the same geometry. So the whole look of the node tree is a bit different of what we're used to with, for example, the shader nodes. So now we want to influence the rotation based on this same distance attribute. How can we do this? Let's do a vector math maybe based on this same geometry. We want to use the attribute distance, and we want to maybe multiply the distance, maybe the x rotation, multiply that by 45 and result in rotation. Okay, so now we get this, and when I move the empty, we're not only changing the scale but also the x rotation based on the distance of the point to the empty. In the past, we really needed something like Sverchok or animation nodes to do this kind of thing in Blender. But now with geometry nodes, we get this powerful tool, and I'm sure this is going to be very, very awesome in the future for things like motion graphics. I mean, just look at with this very simple, we're not even using all of this down here. We're just using these trees, these nodes here, and we already get this really amazing, cool looking thing. All right then, I hope this was interesting for you. I'm still learning all of this at the same time as you are, but I can already tell that this is going to be very powerful. I'm very excited about this new feature, and I'm happy that it will be part of Blender. I also hope that they bring back the particle nodes, because that was also a very cool feature. I don't know why it completely disappeared. You can't even enable it as a developer preview feature anymore. If you want to see more tutorials on geometry nodes, and if you want to stay updated on the development of all of this, do make sure that you're subscribed, because I will stay on top of this, and when there's new features coming out and maybe some new things that I can think of, what we can do with this powerful tool, then I of course will make a new tutorial here on YouTube. So if you like the video, please give it a thumbs up. Stay connected on my socials. Don't forget that I have a Patreon page, and you can support my channel over there. I will put all of these files, although they're not very exciting, on Patreon for you to download. And once again, if you're interested in 3D printing in the combination with a Blender, then please write a comment down below. And of course, if you have any other comment or a suggestion for a future tutorial, maybe based on geometry nodes, then also please write a little note down below. Thanks for watching. Crispy out.